In this example, we are looking for y double prime, so we're looking for the second derivative. To start, let's do the first derivative. So derivative of x to the fourth would be 4x cubed. Then plus derivative of y to the fourth will be 4y cubed, y prime, because every time you do derivative of y, you get y prime. Derivative of 16 is 0. So that's my first derivative, but we want to get y prime by itself. So we're going to subtract 4x cubed to the other side. And then we're going to divide by the 4y cubed. And if you simplify that, we're going to get y prime equals 4's cancel, so negative x cubed over y cubed. So that's my first derivative. Now we're going to use that to find the second derivative. So my second derivative, I'm going to have to use a quotient rule for this. So over here, I'm going to have low d high. So low is the bottom, derivative of the top. So that'll be negative 3x squared. So that was low d high minus high. So leave the top alone. D low, we're going to do derivative of the bottom, but it's a y. So it'll be 3y squared, and then we add a y prime. All over, square the bottom, and away we go. So we've got y to the third squared. Then we want to simplify, but this isn't good enough. Y double prime can't have y prime in it. So we always need to take the y prime and substitute it in for the y prime. So I'm going to reorder this term. I'm going to put the number in front, and then the x, and then the y cubed. Here, I'm going to cancel this double negative, change that to plus, and move the 3 in front. So it'll be 3x cubed y squared. And then y prime, I substitute in what y prime equals. So it'll be negative x cubed over y cubed, all over y to the sixth. You would multiply your exponents. Then I need to simplify the top. It looks really messy. So that first term is going to stay the same. I've got a negative here, so I'll move that in front. I can put my x's together. That'll be x to the sixth. And then I've got y squared divided by y cubed. So that would give me a y on the bottom. Then I want to put these together, so I'm going to get a common denominator here. I'm going to put a y on the bottom and add an extra y on top. So that's now going to be y to the fourth. With that, now I can subtract these fractions on top. So I've got negative 3x squared y to the fourth minus 3x to the sixth all over y to the sixth. From there, I've got a fraction and a fraction, so I'm going to put a 1 on the bottom and multiply by the reciprocal. So I'm going to multiply by 1 over y to the sixth up there. And that's going to give me y to the seventh. So now I've got negative 3x squared y to the fourth minus 3x to the sixth all over y to the seventh. And now that looks pretty simplified. But we actually can go further. On top, we've got some like terms. So, or not like terms, but we have some common factors that we can factor out. So I've got a negative 3 in common, and they also have an x squared in common. So if I factor that out, that would leave me with a y to the fourth minus an x to the fourth. And then we've got something really cool that just happened. The parentheses ends up being what we started with. Or wait, I just took out a negative, so that's plus. But now this is back to the original function. We've got x to the fourth plus y to the fourth equals 16. So this x to the fourth plus y to the fourth that we have right here equals 16. So if you go back to the original function that they gave you, they just said that that equals 16. And if you simplify more, if you put those numbers together, we get negative 48 x squared over y to the seventh. That is your second derivative.